Sarah, do you want to change groups?
Never.
Okay. So we're looking at L7 group meeting quiz.
I'm starting it right now.
Okay.
My cat's laying right next to me. She's been wanting attention. Look, I'll show you. Aww.
Aww. She a little Siamese?
She's a Himalayan.
Oh, okay.
Yeah, I don't know if you are familiar with those kind of cats, but she's like 16 years old, but she's still kicking.
Crazy old for a cat.
Yeah, it is really old, and she's normal. She's not blind or deaf or anything, so
Well, indoor cats can live forever.
yeah.
Like I think three cats or so growing up. Like, yeah, just over the course of elementary school through high school,
Uh-huh.
and all of them died because of cars. So
Oh,
when they're indoor cats, it's like nothing can kill them.
seriously though.
Those
Yeah, she's
tortoises, they
definitely
hang
an
out
indoor.
forever.
Yeah, she's definitely an indoor cat. She's spoiled rotten. Yeah. Anyways, okay, sorry. Had to
Oh,
talk
no
about
problem.
that. Okay, let's see. Question 3. Okay, I gotta get my thing up. Okay.
To the right of positive and to the left of negative. Okay. You get your answer?
Um, okay, is it 0.317?
It's not what I got.
Okay. So, oh, yeah, that's why it's not that. Hold up, I'm typing in the wrong area.
Oh.
Oh, my bad. Okay, there we go. Okay, did you get 0.1745?
Perfect.
Okay. I typed, I guess I wasn't looking and I typed the z-score up in the area. I was like, wait a second, what's going on? Okay. Okay.
Okay. So this kind of goes into your question that you had at the very beginning.
Yeah.
So do you know what the answer is?
Give me 1 second. Okay, I gotta think about this. Would it be okay? Maybe I'm not. I feel like I can figure this out, but which one would be smaller? Okay, I think it's the first one.
For the individual observations?
Yeah.
Why do you think that?
Um, because with the individual, so the law of large numbers applies to the individual observations. And so I'm not sure. What did you
What's
get?
what's the equation for the standard deviation for a parent population?
It is. Are you talking about like z-score?
Um, no, not in this case. I'm trying to think back where it pops up. Maybe because there's two different standard deviations we're looking at. We're looking at the standard deviation of the parent population and the standard deviation of the sample population. And this, even though they're both standard deviations, they actually have different equations because they're being applied to different population groups.
Yeah.
Did you remember what those equations are?
So the sample mean is standard deviation over um, square root of n. And then the standard deviation for the other one is.
Well, actually, let me stop you right there
Is that wrong?
because you actually have it right there without having to solve for it.
Mm-hmm.
Because if you look at the full standard deviation, it is, if you remember, it is the square root of the sum of all the differences divided by n minus 1. Do you remember that long, stupid equation?
Yeah, okay, so it would be the sample means would be smaller
Yeah, because if you
because
think
you're
about it,
dividing it by something.
exactly. Yeah.
Okay.
So for the distribution for the parent population, the first choice, the individual operations,
Mm-hmm.
you have the standard deviation, which is sigma.
Yes.
For the standard deviation for the population of means, it's the standard deviation divided by something, like you said. So
Okay.
as long as that number is greater than 1, that means the standard deviation is going to shrink. And we
Okay.
know that the standard deviation that the n is equal to 3 n is equal to 9.
Okay. Yeah, that makes sense. Okay, cool.
Yeah. So yeah, just keep in mind that there's two different standard deviations depending on whether we're dealing with the parent population or the sample population.
Hmm.
And the sample population is the easy one. It's simply the parent population standard deviation divided by the square root of n.
Okay. And then the other standard deviation is just for, is it the means of means one we're kind of talking about? Like, so I'm thinking about the simulation we had to do for the last lesson, and it was kind of showing us the parent population, and then what was the second one? It was like the mean of that, and then the next one was the mean of means kind of thing. Is that you remember? And we did it together
Yeah, no,
and played around with that.
what the standard deviation for the parent population is, do you remember, I think it was the second week of class, um, where we just used Excel to use math? And it was, we highlighted the
Yeah,
cells and then did equals STDEV
yeah,
and then highlighted the cells. So we didn't
yeah.
even calculate it.
Uh
That's the parent population. So there's an equation for it, but it's really, really confusing and
huh.
long.
Yeah.
So it looks like our teacher isn't having us do it. And when we do need to calculate it, it's just going to be Excel equals standard deviation and punch in the numbers.
Oh, okay. Sorry, I had to let my cat out before she started meowing. She's so needy. Okay, yeah, that makes sense.
Okay.
Okay. All right, number 5.
Here we go. This is the one that we kept messing up.
The sample size increases. Oh. Oh, law of large numbers.
Exactly.
Okay, sorry, I had to like think about that in my head.
No, you're good. Because
Anyways.
yeah, saying spread, and we usually hear distribution and that kind of stuff.
Yeah.
Do you know how spread and standard deviation are associated with each other?
Yeah, so standard deviation is how spread out they are. I just used that word and
Exactly. Yeah. No.
yeah.
Standard deviation is the unit that we use to describe spread.
Yeah.
So just like feet is the unit that we use to describe distance, or
Hmm.
seconds is the unit we use to describe time.
Yeah.
Standard deviation is the unit we use to describe spread.
Okay.
So
Yeah, that makes sense. All right.
yeah, you obviously totally knew it because you just gave me the definition right there. It's just sometimes there's a
I
there's a
didn't really
saying.
connect the dots though that the units for spread is standard deviation. I didn't like.
Exactly. Yeah. No, there's and that's
Mm,
the thing. There's things that you know. In
mhm.
this case, you knew that standard deviation, the larger the standard deviation, the wider the spread.
Yes.
There's things that you don't know, like is there life on Pluto? You just don't know that.
Yeah.
And then there's things that you don't know, which was the
Yes.
standard deviation is the unit by which we measure spread.
Yeah.
So it's always good to make those connections, like you said.
Yeah. And I'm one of those people that I don't think outside the box like that. So I'm like, I don't make those connections on myself. But, it makes sense when you say it. So, yeah. Anyways.
Okay, perfect. More information for the next four.
Okay. Okay, so for this one, which z-score formula are we using? Is it just the normal one we use?
Let's see, Diane earned a score of 160. So going back, what's the difference between the two z-score equations? When do we like not when do we use them, but
Yeah.
what why are there two? That's the question I'm looking for. Why are there two?
Um, so the new one we learned is for the population sample size. So
Say
if
that
it gives
again.
us n, sorry, if it gives us n equals something, then that's a hint to use the second one that we learned.
Yes, and we're not looking at a sample, we're just looking at a single observation, Diane score. So you're totally right.
Okay, cool. Cool. Just wanted to make sure before I did all that math. So I got the z-score 1.045.
Okay, z-score, you said 1.045.
Yes.
Okay, that's what I got.
Sweet.
Okay, so we already have the z-score. What's the probability that someone would score above 160?
So we're kind of doing this in the, which what you call it, the preparation assignment. So would it be 0.148?
Yes, that's what I got.
It.
It's asking above. That means out of the 3 areas on the curve, we are just looking right of the positive z-score.
Yes. So, okay, never mind. Okay, so I got 1 point, oh, I got the same thing. I got 1.045. You got?
Let's see. 1.0. Oh, for the z-score?
Mm-hmm.
A second. And which equation did you use?
So I used the one we used for the last problem, the normal z-score formula.
What's the difference between this and the last problem?
There's the multiple, it's like a sample.
Exactly.
Okay,
Because
so
we have a sample of 5 students. So which z-score would we want to use?
the second one.
Exactly.
Okay.
Now those is totally good. That's the type of thing that you need to be watching for.
Let me try this. Okay. Is it 0.467? I hope that's right.
I got 0.468, just because it was 7.5, so
Oh,
rounding.
yeah, round up. Oh, but that's what you got? Woo, that's exciting. Okay.
And that's actually something you can do to check yourself when you're having problems like this,
Mm-hmm.
because it's asking for a z-score for just a single observation,
Mm-hmm.
and then it was asking for a z-score for a sample population for a sample. You
Mm-hmm.
got the exact same score last time because you didn't take into account, because well, the average is actually the same as the single observation,
Yeah.
and that's why you got the same answer. But it
Mm-hmm.
should have been a red flag that, oh, the standard deviation
Yeah.
has to be smaller because this is a population of 5. This is a sample of 5 as opposed to a single observation.
Yeah.
So
Yeah,
that
right
was
when I got
actually,
it, I was like, oh, I've gotten this answer before.
yeah. Because,
Okay.
yeah, I was working on it when you gave the answer that was a red flag. I was like, wait a minute. We're dealing with a sample, and the standard deviation for samples are always smaller because you have to divide by the sample size.
Yeah. Oops. Okay, number 8. Oh. Hmm. Um, did you get 0.319?
3199, round to 4 decimal places.
Oh, do we round to 4 decimal places?
Yeah, that's what it says.
Oh, okay.
Usually it's just 3, but because it was
Double.
0.3199,
Yeah.
yeah, the answer there would have been 0.32 or 4 decimal points.
Okay. Sweet.
And conceptually, does that make sense to you that we have the exact same score because the average of all these guys was 160 and Diane's score was 160? Does it
Yeah.
make sense to you that if you were to choose just a single person, just one random person, that the odds of someone scoring as high or higher than her is only 14.8%? And yet, if you take 5 students and average their score, then the odds of taking another 5 students and averaging their score, the odds of the score being the average being the same jumps up to 46.8%. I guess 30, I should say 31.9%. Does that make sense to you conceptually?
Yeah. Um, yeah.
Because you remember how the mean of the population, the parent population, so everybody who takes the test,
Hmm.
and the mean of the sample population or the population of samples,
Hmm.
remember how those two are the same? We just have to discover it.
Yeah.
So the means are the same, but the standard deviation is a lot lower because for the population of samples, you have to divide by how big your sample is.
Hmm.
And since the standard deviation is smaller, that means the spread is smaller, which means that you have less wiggle room to move back and forth. So all of the numbers are going to be more closely lumped together.
Yeah.
Does that
Yeah,
make
that
sense?
makes sense.
That makes sense conceptually?
Yeah.
Because yeah, like I said, the standard deviation for the population of samples, well, standard deviation is a measure of spread,
Mhm.
and the standard deviation for the population of samples is the normal standard deviation divided by some number. So that means the spread's going to be even less, which means all the numbers are going to be closer together.
Yes. Yeah, that makes sense.
Okay. Okay, and what'd you get for question 10?
Um, Approximately normal,
And why is that?
because the sample mean is over 30.
Perfect.
Easy, easy.
Okay. And what are your thoughts on question 11?
Um, do How do we find the mean?
So here's a question for you. What do we know about the mean for the population of samples versus the mean for the parent population?
Um, they'll be similar, right?
Similar?
Um, Smaller? I guess they'll be smaller than the parent population. Oh gosh.
You're thinking of standard deviation. You're
Okay.
right with that. Do you remember that applet that we had where it gave a parent population and then we chose how big the sample we wanted to do and then how many repetitions we wanted to do?
Yeah.
So when we're doing that, did you see a pattern of what the mean for the sample population was as it pertained to the parent population?
Wasn't it? I thought it was similar. Cause like,
Not just similar, it's exactly the same.
oh, okay.
Provided we do enough repetitions,
Yeah.
it will become exactly the same. And when you saw like when we did 10,000 repetitions, it was exactly the same.
It's like spot
But
on.
yeah, but when we did fewer, like 5, 10, 15, or something, it got really close.
Yeah.
But the idea is that if you keep going on, it will be exactly the same.
Oh, so is it just does it give us the mean in the question? No, it doesn't.
So this is one of those multi-part questions, so make sure you scroll up to the top.
Yeah. Oh, is it 3.5?
Exactly. Yeah.
Oh my gosh, what is wrong with me?
It
It's like so easy. It's like ah.
you're overthinking it, and that's
I was like, what formula I'm like, what formula am I using? I don't even
it's something you need to stop yourself with because overthinking gives you the wrong answer, but overthinking is always better than having absolutely no clue.
I know. Ah, gosh, it was right there. That's Anyways, okay. Oh, I mean, so is it 0.7?
Close. What do we know about the standard deviation for the parent population versus the standard deviation for the population of samples?
Population of samples will be a smaller standard deviation.
Smaller by how much?
Um, I don't know. By how many, by the size of the sample?
Oh, you're so close. It is dependent on how big of a sample we take, but
Uh,
it's not directly related to it. We do something to that number.
is it? Like looking at my notes. Is it super easy, super obvious?
Yes. Yeah, it's just one simple thing. You're totally right with the larger the sample we take, the smaller the standard deviation is, but it's
Mhm.
not as simple as dividing the standard deviation by n. We divide the standard deviation by what? We do something to n.
Um, do we square root it?
Exactly.
Oh, gosh.
So you're totally right that it's smaller, and it's smaller because of our population size.
hmm
So rather than dividing by 81, you'll want to divide by just 9.
Okay. Okay. So is it 0.077777?
Yeah, that's what I got.
Okay. Okay, so okay.
Okay, so the probability for GPA of 81 randomly selected students will be less than 3.3. So what's the very first thing we want to do here?
Do we want to find a z-score?
Exactly.
So we would do 3.3 minus the mean, which is 3.5, right?
Yes.
And then we're using the the first z-score formula, right?
Why do you say that?
Um, be, mm, no, it would be the second one because it's um sample.
Exactly.
Okay.
We're working with a sample of 81 students as opposed to just a single observation.
Okay. Ooh. I got negative 23.076.
Okay. So first, before I give you my answer, just let's think about this conceptually. So that z-score, what was the z-score you got again?
Negative 23
Okay.
point,
So imagine the graph in your mind. Where would negative 23 lie?
like, way.
Yeah, so it'd be way out there.
Yeah.
The mean is 3.5, right?
Yes.
And the one that we're dealing with is 3.3, which is slightly lower than 3.5.
Hmm.
Do you really think it's going to be in the bottom like
No.
0.0000001 percentile?
Yeah, no.
Okay. So that right there gives you a red flag that you did the calculation wrong.
Okay. I'm not sure what I did wrong though.
But that's good because then that means you won't use the z-score on the next step, you know. If you catch yourself early on the earlier steps, then you don't end up wasting more time.
Yeah. So I did 3.3 minus 3.5 divided by 0.078 divided by square root of 81.
Let's see. You are super close.
What did I do wrong?
So
Oh, less. Oh, wait. What is it? Whoa, I'm really confusing myself. Do I need to use the applet for this?
we will eventually, but right now we want a
But right
z-score.
now yeah, okay. Um,
So what's the equation?
so it's
Just in the terms of variables, symbols, you know.
so it's sample mean minus population mean over standard deviation divided by square root of sample size.
Yes, perfect. And what did you use for your standard deviation?
Um, I used our answer for 12. That's wrong. Should I not have used that? Oh, I should have used point 0.7.
Yes.
Dang it. So, wait. What's the difference between these two standard deviations? Oh, one's the population and one's the. Okay. Okay. Negative negative 2.571. Where's the score?
Not what I got. Um,
That's not what you got?
yeah. And think again, just kind of conceptually, we realize that standard deviation is smaller for samples. So I guess you could say that 3.3 could be the bottom 5%, but that's still, you think GPAs would be a little bit more spread out than that.
Huh. What am I putting? What am I doing wrong? So I did 3.3 minus 3.5 divided by zero point 0.7 divided by square root of 81. Am I supposed to use 81? Is that what my problem is?
No,
It's
I'm using,
81.
let me double check, make sure I'm not the one in the wrong here. Okay. No, I still got a different number. There is something you can do to simplify your equation, and it may just be plugging in so many numbers, something might get lost along the way. What's the square root of 81?
Um, let me, 9.
Yeah. So try the equation again, but instead of square rooting 89,
Just
because
divide it by
yeah,
9.
just put 9 in there. Because adding an extra function of doing a square root may be messing with your order of operations.
Yeah. No, I still got the same answer. Negative 2.571.
And you're using 3.3 divided by 3.5 divided by zero point 0.7
Oh,
times 9.
I'm doing minus 3.3 minus 3.5.
Yeah,
Okay.
and that's what you're doing?
Divide. Yeah. So
That's
3.3 minus 3.5 divided by zero point 0.7 divided by 9. Is that what you got?
what number did you get again?
Negative 2.571.
That's super weird.
That is weird.
Let me just screen share real quick. Okay, so this is what I'm doing.
Okay.
So here's the sample, the sample, right? 3.3.
Uh-huh.
The average 3.5, n is 81, and zero point 0.7 is the standard deviation.
Okay.
So we have is equal to, oops, equal to our sample minus the mean divided by zero point 0.7 times square root.
Oh, wait.
And that's how I'm getting 0.03.
Click on your form. Click on that cell again.
Mm-hmm.
Oh, okay.
So is there something we did differently?
Um, I divided my standard deviation by my square root sample size.
Oh, okay. That makes sense. Because, yeah, when you divide, when, yeah, you have a division in your denominator, then that flips it. So you end up timesing it by 9 instead of dividing by 9.
Oh, oh, that's beyond my skill level. Okay. Huh. I don't know. That's weird. I don't know.
Okay.
Let's use
So have
your
you done the
answer.
calculation again?
Huh?
Have you done the calculation again?
Um, so when I times it, it's negative 0.031. Is that what you got? That's what you
Yes.
got.
Perfect. Yeah.
Okay. Alrighty.
Okay. Not saying you have to. You may want to you may want to learn to use Excel
Yeah,
because it's super easy for me. But again, that's up to you.
yeah.
I just learned Excel just helps me so I don't mess up with order of operation type things, you know.
Stuff I mess up on all the time.
Okay, so where
Okay.
did that app go? There we go. Okay. So have you got an
So
answer?
would we highlight the left-hand side and the middle side?
Which way are you going?
Oh, oops, someone's calling me. Um,
So first off, what's it asking for?
less than 3.3.
Okay. So what would less than, and what's the z-score we got?
Uh, 0.035.
Oh, try again.
Uh, 0.03. Oh gosh, dang it. Never mind. Wait a second. Oh, 3.2.
Okay,
Dang it.
try again.
Okay. Okay, so would it be 0.4872?
Yes, for the area. How are you getting that?
I highlighted the left-hand side.
Okay. And why aren't we highlighting the middle side?
Because it's just asking what is less than.
But we could highlight the middle. Do you know
Um,
when we would highlight the middle?
when it's asking if it's less than or equal to.
Not necessarily. So 3.3 is less than 3.5, which is the average. So what happened to our z-score?
It got smaller. Wait. Okay, hold up. um,
So here's the difference.
uh,
Here's a question. Why does it matter? Because the equation is the sample minus the mean over yada, yada, yada. Why
yeah,
does the order matter?
the order of putting the sample minus the mean.
Yeah. Why do you have to do the sample before the mean rather than sample before the mean or the mean before the sample? What difference does it make ultimately?
Um, um, I mean, it changes the numbers. Um, like if you did, I mean, yeah, if you change the order, you change the numbers.
In what way?
I mean, they could be bigger or smaller depending on if
Could
the
they?
sample is bigger or smaller than the the mean.
Well, would the number be bigger or smaller? What's just off the top of your head? I know you know this. What's 10 minus 5?
Um, -5.
Wait, what?
Wait, 10 minus 5. Okay, sorry. 5. It's 5. 10 minus 5 is 5.
Okay, so it's 5 minus 10.
-5.
Yes. So in this case, we're dealing with a mean. I mean, we're dealing with a sample that's smaller than the mean, which means our z-score is going to be negative, right?
If the sample is smaller than the mean.
Our z-score becomes negative because 3.3 minus 3.5 is negative 0.2.
Yes. Yes, you're right.
And so because we're given a negative z-score, we're only looking to the left of the first z-score number, which is that negative z-score number.
Okay.
If it was say, what's the probability of less than 3.7, you would still have 3.7 minus 3.5, which would be zero point 0.2 again, but it'd
Mhm.
be positive that time. So we'd
Yeah.
get the exact same z-score, but we get the positive z-score so that we'd be looking at the z-score that's further along on the graph.
Yeah, okay.
So that's when you would highlight the left and the middle section is
Mhm.
if it's asking for less than and you get a positive z-score.
Okay.
So does that make sense?
Yes. So
Okay,
because we got a negative z-score, we only highlight the left-hand side.
exactly.
Okay. I should write that down. If I could find my pen. I'll tell later, I guess. Okay. That makes sense. So you got 0.487, right?
Exactly. Yeah.
Okay. Okay. So for this one, would you highlight the middle and the right-hand side?
Exactly.
Okay.
What answer did you get?
Um, my thing just messed up. Um,
Because there's actually two ways to do this, and they're both easy. One is simply just highlighting, like you said, the middle and the right, or you can just do 1 minus our previous answer because we're looking at the rest of the graph.
oh, yeah, you're right. So it'd be 0.513, right?
Let's see. Oh, I messed up my z-score. Hold on a second while I double check.
Yeah, I tried to click the middle and it like messed up my z-score. So that's why I was like, wait a second.
Yeah, 513.
Yeah. I can't highlight, it won't let me highlight the middle section without moving it. Are you having that problem?
Yeah, I was having some issue with it, but what do we know? What happens if you highlight all three sections?
It will be equal
What's
to
the area?
1.
Yeah. So if we had one section highlighted in question 13, and then
Mhm.
we just highlight the other two sections in questions 14, what's a quick equation that we could use?
1 minus our previous answer.
Exactly.
So did you get 0.513?
Hmm.
Okay, sweet. Whew, it's a long one. I don't know where I put my pen.
Okay, what are your thoughts on this last question?
Sorry, it took me a second to plug in those numbers.
Oh, not a problem.
Um, so I got -0.04.
Okay.
No?
No, that's the z-score that we need.
Okay. I was like, oh, dang it.
So you got the z-score, and then the next question is, what parts of the curve are we looking at?
Okay, so find the probability the random sample of will have a weight that is as extreme or more extreme. So we're gonna put in the applet z-score. Four. And we want to do highlight the middle section and the right hand side.
Okay, why are you thinking that? Because yeah, like this is worded extremely weird, but why are you
Yeah.
thinking? Walk me through your thought process.
Okay, so for sure the right hand side will be highlighted. Um, okay, wait, let's see. Oh, this confuses me a little bit.
Did you read the note at the bottom of the question?
Oh no. As extreme or means that we're not only interested in values that are lower. Hmm. What?
Yeah, it's worded really weird, but let's parse this down. Okay. So as extreme or more extreme means that not we are not only interested in values that are lower than the ones we observe. So that first part, lower than the ones we observe, which section would we highlight?
The left hand side.
Okay, perfect. We are also um let's see, but also values that are as far away from the mean as ours, but in the opposite direction.
Okay, so it would be the left and right hand side, but not the middle.
Exactly.
What?
Yeah, it's worded really stupid.
Hmm. Okay, so it'd be 0.968.
And that's what I got.
Okay, that's super weird. I hope we don't have to do that on the test. Okay, moment of truth. How well did we do? Okay.
Ouch.
Oh
It's
no.
had some rounding errors. Have you submitted yet?
No. I should go back then, right?
Okay, so don't submit yet
Okay.
because it says we missed questions 8, 9, 13, 14, and 15.
What?
Yeah. So let's look those over again.
So 8, 9, 13, 14, and 15.
Yeah, the last three.
Dang. Okay. Huh.
Okay.
We got 8 wrong?
I got 5.
No, I mean like we got number 8 wrong. That's
Oh, yeah. Yeah. So I'm looking this over. I'm like, what the heck? So let's try this again real quick. It's just a rounding error. Got a mean 150.8. Oh. For some reason I feel like I just used a mean of 150 instead of 150.8. I don't know why. So let's check real quick.
My I wrote it down and I put 150.8.
Okay.
But let's check. Oh.
Do you find out what we did wrong?
So I just typed it in again. And I got 1.045. But for 8, I only put 0.468. Oh wait, I think that's why.
Oh, I think okay. No, I think I see what we did wrong, and this was totally on me.
Well, what do we do?
You were totally doing it right earlier. When you're dividing, yeah, I got confused with the equation, just plugging it in all at once. So we should have sigma divided by the square root of n, whereas in the equations, I was putting them together in the denominator and timesing them, which is wrong. Real quick.
Oh, so we do divide them.
Yes. So,
Okay.
okay. So what's the new answer you got?
So you're on 8, right?
Yes.
Okay. And we're using the second z-score.
Yes.
No. Okay. So 2.337.
Are close to that. Oh, wait. The z-score. The z-score, what equation did you use?
The second formula.
What numbers did you plug into it?
So I did 160 minus 150.8 divided by 8.8 divided by square root of 5.
You got, what was the number again?
2.337.
Still doing something wrong here. Give me another second.
Okay, no problem.
Okay, so you said 2.3.
337.
Okay, yeah, I got that.
Okay. So is that our new answer for number 8?
Yeah, so plug that into number 8. And then we'll follow through with number 9 and then do the same for the last 3 questions and have you submit and see if we got them correct that time.
Okay. Alrighty. So we got number 9 wrong, right?
Yeah, because we used the z-score from the previous question, which was totally wrong.
Okay. Um, what part of the applet do I highlight?
So the question is asking what is the probability that it would be greater than the sample mean that we got?
So is it just the right-hand side?
Mhm.
Okay. So 0.0097.
And that's what I got.
Cool. Okay. And then question 13.
Which was, again, just my bad. We just used the wrong equation.
You're good.
So let's plug in the numbers again.
For the standard deviation, you're using 0.7. Correct?
Check. Yes, 0.7 for the standard deviation.
Okay. Okay, so I got negative 2.571. Oh, for the z-score. Oh, wait. Yeah.
Crazy number because I was still using the average from the previous. So it's like 3.3 minus 150.8. So I was having a huge number. I was like, I don't think a z-score of 126 is right.
Yeah.
Three minus 3.5 divided by zero point 0.7 divided by 9. Okay. You said negative 2.57?
Yes.
Okay, perfect.
And then we put that into the applet, right?
Let's see, is it asking for the z-score or it's asking for the probability? So yeah, we'd want to put that in the applet.
So is it 0.995?
Let's see, depends on which area you're highlighting. So it's asking, so what's the z-score you got?
Negative 2.571.
Okay. So it's asking which ones would be less than 3.3, and we got a negative z-score, so which area would we highlight?
Just oh, dang it, we talked about this already, didn't we? Um, just the left-hand side?
Yes, because that's the negative z-score.
Man, that is probably the only thing that confuses me is what part of the applet to highlight. I don't know. I don't know why it confuses me so much. So it would be 0.005.
Yes.
Okay, and that's for question 13, correct?
Yeah.
Okay. Oh, okay, so the exact opposite. So this one would be 0.995.
Yes.
15. Okay, so for 15, I got for the z-score, I got negative 1.92.
Actually had it. Give me 1 second.
Okay, no problem.
What'd you get?
Negative 1.92.
Yeah, perfect.
Awesome. And then, so for
Then
the
this
prob,
one, do you remember which areas we highlight?
um, oh, the left and the right hand side, but not the middle.
Yes.
Yeah, okay. 1 point. So it'd be 0.054. How many decimal points? Okay, so it'd be 0.055.
Okay, that's what I got.
All right, moment of truth. Let me submit this.
Okay.
We got 100.
Okay, perfect.
Whew, whew.
Okay. Sorry for confusing you on that equation.
Well, it stinks because if it's like the questions build on each other, so if you get one wrong, then all your other answers will be wrong. You know what I mean?
Yeah, which makes me wonder. I wonder how the test is going to be set up because I'm assuming that there's probably be a way to give partial credit so that this kind of stuff doesn't happen.
Yeah,
Maybe she'll just have questions not build on each other. I don't know.
yeah.
We'll
I
see.
hope I hope not because I feel like there's so many human errors that could be made in these. So, anyways, yeah.
Okay, so we got 100%. The next, so there is another lesson before the test next Tuesday, but it's just a review.
Oh,
So
is it? Oh, thank goodness. I was
yeah,
like,
so
no.
we'll we'll meet up on Tuesday.
Okay,
And yeah, if you have any questions, we'll go through the quiz. And if you have any questions, we can just have a review session before we take the test on Wednesday.
totally, totally, totally. Cool. Works for me.
Okay. And then let's see. One last thing before we go. I would say the first song you should listen to from Dear Evan Hansen, do
Yes.
Waving Through a Window. If that one if that
That's
one
the
doesn't if that
yes.
doesn't catch you, then you're not going to be interested in it.
Okay. That's the one I have pulled up. So
Okay. Yeah,
that's what I'm listening
hold on a second.
to.
Yeah, this is the one. Yeah, so give it a listen.
Okay.
If you're just kind of like meh, then the musical's not for you and you can give it a pass. But start with that one, okay?
Okay, cool. I will.
Okay. I'll see you next week.